If you thought the latest images from the James Webb Space Telescope were impressive, what you're about to see may completely change your perspective. A new space telescope has quietly begun sending back images so vast, so detailed, and so revealing that astronomers are rethinking some of their assumptions about the universe itself. The Euclid Space Telescope has released its first major observations, and these aren't simply beautiful photographs of distant galaxies. They reveal enormous cosmic structures, hidden patterns shaped by invisible forces, and a universe that appears far more complex than we once imagined. Euclid is unlike traditional space telescopes. It was never designed to focus on a single nebula or capture close-up portraits of galaxies. Its mission is much more ambitious: to create the largest and most detailed map of the universe ever attempted. Launched by the European Space Agency in July 2023, Euclid operates nearly 1.5 million kilometers from Earth at the Sun-Earth L2 point. From this stable location, it can observe the cosmos with remarkable precision, free from much of Earth's interference. Its ultra-wide field of view allows it to capture enormous sections of the sky while maintaining extraordinary detail. Instead of seeing individual galaxies in isolation, Euclid observes how millions of galaxies connect across vast distances. What makes this mission especially important is that Euclid isn't only studying visible matter. It is searching for evidence of the invisible framework believed to shape the entire universe. Using a technique known as weak gravitational lensing, Euclid measures tiny distortions in the appearance of distant galaxies. These distortions occur when massive concentrations of matter bend space itself, subtly altering the path of light. By measuring these distortions across millions of galaxies, scientists can begin mapping the distribution of dark matter, the mysterious substance that cannot be seen directly but appears to dominate the universe's mass. When Euclid released its first large-scale sky mosaics, researchers were astonished by what they revealed. In a relatively short observation period, the telescope captured millions of galaxies across a region of space hundreds of times larger than the full moon. Yet this enormous dataset represents only a small fraction of the survey Euclid is expected to complete during its mission. Scientists can zoom from gigantic cosmic structures spanning billions of light-years down to individual galaxies while maintaining exceptional clarity. For the first time, they can examine how matter is distributed across immense regions of the universe in a single coherent view. One of the most fascinating discoveries comes from galaxy clusters such as Perseus. Within these regions, Euclid has revealed hundreds of previously unseen dwarf galaxies hidden among brighter objects. These faint galaxies are more than cosmic curiosities. Because dwarf galaxies are highly influenced by dark matter, they serve as valuable tracers of invisible mass. The discovery of so many previously undetected dwarfs suggests that dark matter may be distributed in ways more complex than many earlier models predicted. Euclid is also uncovering faint stellar populations, ancient low metallicity stars, and ultra-diffuse structures that were difficult or impossible to detect before. In some regions, it can reveal the faint outer halos of star clusters, exposing clues about their long histories and the processes that shaped them over billions of years. Even more intriguing, observations are beginning to reveal rogue planets and free-floating planetary mass objects drifting through space without parent stars. Together, these discoveries paint a picture of a universe that is far more crowded, dynamic, and interconnected than we once believed. And perhaps the most remarkable fact is that this is only the beginning. The images released so far represent just a small preview of what Euclid is expected to uncover during the coming years. If these first observations have already transformed our view of the cosmos, the full mission may reveal structures and patterns we have not yet imagined. As Euclid continues its mission, a larger pattern is becoming impossible to ignore. Galaxies are not scattered randomly throughout space. Instead, they appear woven into an enormous cosmic web, vast filaments of matter stretching across hundreds of millions of light-years. These filaments intersect at dense nodes where galaxy clusters form, while immense cosmic voids separate them. For decades, astronomers predicted the existence of this structure. Euclid is now revealing it with unprecedented clarity. Through gravitational lensing measurements and galaxy mapping, scientists can observe how matter is distributed throughout the universe on scales never before possible. The result is astonishing. The universe appears less like a collection of isolated objects and more like an interconnected network built upon an invisible framework. At the heart of this framework lies dark matter. Unlike ordinary matter, dark matter emits no light and does not interact with electromagnetic radiation. It cannot be observed directly. Yet its gravitational influence shapes galaxies, clusters, and the large-scale structure of the cosmos. By measuring subtle distortions in the shapes of millions of distant galaxies, Euclid allows researchers to reconstruct detailed maps of dark matter distribution. These maps reveal enormous concentrations of invisible mass bending space itself and altering the path of light across billions of light years. What makes this realization so profound is that the visible universe may represent only a small fraction of cosmic reality. Stars, planets, nebulae, and galaxies are the structures we can see. But beneath them lies an invisible foundation that appears to control how matter gathers and evolves. Euclid is also looking deep into cosmic history. Some of the galaxies it observes are more than 10 billion light-years away. Their light began its journey when the universe was still relatively young. By comparing these ancient galaxies with more recent ones, scientists can trace the growth of cosmic structure across billions of years. Early results suggest that galaxies and galaxy clusters may have formed faster and earlier than some models predicted. If confirmed, these findings could challenge aspects of our current understanding of gravity, dark matter, and cosmic evolution. Another area attracting intense attention involves dark energy, the mysterious phenomenon believed to drive the accelerating expansion of the universe. Euclid's mission is specifically designed to investigate whether dark energy has remained constant throughout cosmic history or evolved over time. This question is critical because the answer may determine the ultimate fate of the universe. Recent observations have revealed subtle tensions in measurements involving expansion rates, galaxy clustering, and matter distribution. While these discrepancies remain small, they continue to attract scientific interest because they may hint at new physics waiting to be discovered. Perhaps one of the most extraordinary aspects of the mission is the sheer volume of data it will produce. Over the coming years, Euclid will map billions of galaxies in 3 dimensions. The dataset will be so vast that advanced artificial intelligence systems will play a major role in identifying hidden patterns and relationships. In a sense, humanity is building machines to help interpret a universe too large and complex for any individual mind to fully comprehend. Yet every new discovery brings a deeper realization. Euclid is not simply creating a map of the universe. It is creating a map of our ignorance. The more precisely we observe the cosmos, the more we discover how much remains unknown. Dark matter dominates cosmic structure. Dark energy drives expansion. Gravity behaves across scales we still struggle to fully understand. And yet, somehow, all these components work together to produce a universe of extraordinary order and precision. Perhaps the most profound lesson from Euclid is this: galaxies are not the architects of the universe. They are the result. Invisible dark matter structures formed first, creating a gravitational framework within which galaxies later emerged. Everything we see today may be built upon foundations that remain hidden from direct observation. Euclid is not showing us a different universe. It is revealing the universe that has always existed around us, one whose deepest structures have remained invisible until now. And as its mission continues, the greatest discoveries may still lie ahead.